Okay. So let's look at the homework for today. I know I was extremely late in putting the Dropbox up. I usually try to do it right after class, but I must have zigged when I should have zagged. So it is what it is. But you saw my note in Slack. Uh, I mean, obviously, technically, I gave the assignment in class, so everybody should have done it anyways. But if you happen to not do it because you didn't see a Dropbox, then submit something today that just says count my next assignment twice, and I'll do that. Just give me something to in the Dropbox for today. The next assignment's actually going to be the same thing anyways, because I'm going to teach you about GitHub today, because as our code's going to start getting more and more complex, we're going to start needing um, more, I don't want you to have to attach a zillion files. I want you to be able to just give me a link and I can see all your files. But I'm going to have to show you kind of a special way of doing that, but we'll talk about that here in a few minutes. Okay, so let's look at what we were trying to accomplish for today. Hide floating meeting controls that. All right, so for today, we have several things on the screen. We have our player one, our player two, and last time, if you remember, we put this destination object in here. And I want to talk about that a little bit more today. And, with the idea of what if I want my player one to move towards this destination and what are some of the side effects of doing that? I gave you the hint at the end of class that um, you would be able to do this. Well, I suggested you look at something, a static method in vector 3. So if we go to the vector 3 documentation, so here's vector 3, and we go down to static methods. So we know that when a method is static, that means it's owned by the class. Therefore, we call it using the name of the class in which the method was defined. So in this case, we're dealing with the vector3 class. So all these methods are defined in the vector3 class. So the static ones we would call by saying vector3 dot. All right. Now, the one I mentioned to you to look at, we're going to look actually at a couple different ones today, but was this one called MoveTowards. All right, so MoveTowards calculates a position between the points specified by the current and target, moving no further than the distance specified by max distance delta. So let's look at that. So here's the function. It's called MoveTowards. It's going to return a vector 3. It's going to take in a vector 3 as a parameter, and that is the current location. So the vector 3 current, if we want our player 1 to move towards our destination, the current location would be player 1's position. Vector 3 target would be the position of our destination. And then the max distance delta, this is like the amount we want to move between time slices. All right, so we're going to probably have like a speed, and then we want to use that time dot delta time that we've used before. And I mentioned that in class last time as well. Okay. So let's go and look at this. I've already put a little bit of code in so we can expedite through this, because really the solution was one line of code if you wanted to write it. So one thing I did here is I did change from fixed update back to update. Update's going to give us the smoothest experience because this gets called every single frame. Just know that fixed update can be used in certain circumstances when you really care about the kind of fairness across multiple platforms, or maybe you even just use it for specific things. Nothing says you can't have an update method as well as a fixed update. Both of them will get called in their own time. Okay, so notice up here, I just created a private field called speed. You can make it public if you want to give the user control over it inside of Unity. I didn't, so I just set it to 5.0 float. You can mess with it for what's the right speed. Um, so I didn't change anything in start. So then in update, I'm setting, and again, this is actually, I didn't even write this the way I like writing it. So even though this dot transform we've seen is the transform of the game object this is attached to, I like, at least from a teaching perspective, to be very explicit and say, I am talking about this script. I'm talking about the game object that owns this script. I'm talking about that dude's transform, and I'm specifically talking about the position component of that transform. So this really spells it all out. So until you get comfortable with kind of thinking about the programming from that perspective, reading code like that, I would encourage you to be as explicit as possible and focus less on, oh, well, this works, so I don't want to mess with it. It's much more important to understand what's going on than it is to just have it working. Ultimately, obviously, we want to have things working, but in the absence of that, we'd rather be moving our education towards learning the stuff better. All right, so inside of update, every single frame, we're going to be updating this dude's position. All right, and we're going to update it by calling the MoveTowards function, which is a static function we just looked at. So that means we call it using the class in which it was defined in, which is vector3. So vector3 dot MoveTowards. And when I hover over this, you see it shows me the documentation of what are the parameters. So it's the current location, where we're trying to go to, and how far do we want to move in this particular frame. All right. So the current location is where our game object currently is positioned, wherever he is on the screen, this particular frame. All right. Destination is going to be where we're trying to go. This is the destination game object's position. Remember, we made this guy public and we drug him in. That was our pill shaped guy, our capsule, whatever, from the screen. So that's going to be his position. And then the speed we're going to go at is, I think I had it at 5.0. So whatever the speed was times time dot delta times. That's going to be a fraction of a second, right? Because remember, time dot delta time is the amount of time that has passed since the last time this guy was called. And the last time he was called was exactly one frame ago in our code here. So this is the amount of time that has gone by during a frame. So this will be some fraction of a second. Tiny, tiny number. So when I take the speed of 5 and I multiply it by, I don't know, let's just 0.02, it's going to be a tiny number is the distance we want him to travel this particular frame. All right, so just kind of wrap your mind around what time that delta time is giving you. All right, so that's what we're going to do. So every single frame, we're going to be moving just a little tiny bit towards that destination. That's what MoveTowards does. All right, so let's go back to this. We'll go ahead and run it. And we see our dude moving towards that. Okay, so now we see some weirdness. Let's talk about the weirdness. So in the ideal world, we probably, he's just banging around in there. So in the ideal world, we probably want him to kind of stop when he gets to that location. So let's look at a couple of solutions to this. And we want to look at kind of improving solutions. So as a starting point, it looks like he's kind of bumping into stuff. So if we take our destination and we say, look, I don't want this guy to have a collider associated with it. He came with the collider because we drug a capsule out there. I think I mentioned last time we could have used the generic game object, but we drug a capsule out there and capsules come with a capsule collider. So one thing we could do is just turn his collider off. All right, so now no longer does he collide with stuff, so physics won't play a role. Okay, so now our guy comes in and pulls to a stop, but we're not quite there yet. I'm going to talk about that here in a second. All right. Now we might say, well, I also don't want to be able to see that capsule. So I'm going to go ahead and turn the mesh renderer off. So now he disappears. All right. Realistically, by most measures at this point, he's an empty game object. You know, the material we have here, we can't see because we've turned off the mesh renderer. And the capsule up here, we also can't see. Well, that mesh filter, that has to do with how things interact with it. It works with the collider. It works with a couple of other things as well. Check something here real quick. All right. So it's telling me my input is temporarily not working yet. It seems to be working fine. So that must just be a bug. Hide meeting controls. Okay. So realistically, because we've turned off the collider and we've also turned off the renderer, which makes you see it, this guy's an empty game object by all intents and purposes. So nothing really kept us from coming over here and just creating an empty game object. We're just using it for a location to get us to a place without having to kind of figure out where a vector 3 is on the screen and hard code it into the program. It kind of lets us cheat with locations, giving us waypoints or whatever. But we effectively turned our capsule into an empty game object here. Okay, so we're going to, we turned off the visibility of it now. So we'll go ahead and run it. We'll see that our dude runs up to what seems to be nothingness and stops. Okay. Now, this looks like everything is all well and good. Yet we are still, we go back to the code, every single frame we are trying to move towards something, and we're trying to update the position of our dude. All right. Now we see that visually it's actually working just fine. So maybe this isn't the end of the world, but maybe we want to wrap this guy in an if statement and only even try to move to a position in the event that we are not already there. So we might say something like if this dot game object dot transform dot position is not equal to this dot destination dot transform dot position. So as long as those two dudes are not in the same place at this point, only under that circumstance will we try to move. Yes, we're still asking a question every single time through update, and depending on the complexity of our game, we may want to consider whether that makes the most sense or whether we want to have something like this inside of something called a coroutine, but we'll deal with that stuff later. But for right now, we're basically saying I'm going to ask a question once per frame, and depending on the answer to that question, I may or may not try to update this particular game object's position. So we'll come back out here. We'll try to run this dude. He's zipping over there, and now he stops. All right, so even though we visually are experiencing the same thing, under the hood, behind the scenes, we are not actually trying to update this transform's position through using the MoveTowards function. Now, honestly speaking, we could go through some hoops to try to figure out if one is necessarily better than the other, because I mean, this guy is definitely going to do some math. He's going to be doing some linear algebra for the position between two vectors, and but the way it's going to be, it's not actually going to update. So basically, this is going to calculate the position that this should become. So it's entirely possible that MoveTowards doing its math is actually faster than asking the question of should we do that math. And if we keep updating this game object's transform to the identical position as it was last frame, maybe that's not a big deal. So we could go down a path where we try to find out if this is actually faster the way we have it written this way, as opposed to just doing the math every single time, knowing that once we've arrived, we are no longer dealing with, uh, we're no longer going to see movement, but it's still doing math. But in this case, it's not even going to try to do the math. All right. So I wouldn't necessarily say one is going to be drastically better or worse than the other, but my opinion would be that this is better better programming practice to ask the question and only do something when we should be doing it. Okay, now a couple of other things to look at. So if we go back to the documentation here, just go back one thing. And we start looking at vector threes. We see all sorts of different things. One thing that's kind of nice is uh, just something to keep in mind is we do have a function for vector threes where I can give it two different vector threes and it'll give me the distance between those. So if you think about it like a line, how long is that line if we drew a line between two game objects, something like that. Sometimes that distance might be helpful. Maybe in a game, you might decide, okay, well, I'm going to stop moving as soon as the distance is less than 1 or something like that. So instead of occupying the same space, you might say, well, let's just kind of get them close to each other and then stop. All right, so I could come out here and I can do something like, instead of asking, are they the same? I can say something like vector3 dot distance between those two guys. So that's going to give me a floating point value is less than, I don't know, let's say 3.0. Let's see what that looks like. All right. So presumably this isn't going to get us right on top of it. This is going to get us a little bit of a distance. We'll have to see what kind of distance we're dealing with the 3.0, but all right. So here. Okay, 3.0, it is way too big. Which maybe makes sense on scale here. So let's say 1.0. I presume that's the issue here. Otherwise, we might want to just print it out and see how it's changing. All right, let me go out here. I'm going to go ahead and just print out the distance, see what kind of value it is. Print that guy, every single frame. So let's just see what it thinks the distance is between the two of them in the console. That'll help us decide what we need to say for less than a distance. Actually, it should have been greater than. Keep doing this as long as it's greater than that distance. That was my bug anyways. But let's look at the distance anyways. I was saying only move to a position if we're very close is how I wrote it before. Now I want to write it as only move there if we're farther away than one floating point value. So now he should at least move. Okay, so that's one. And we see it's 0.99, whatever. Let's go back to my 3 value and let's see if that kind of runs them up on a position. The reason I want us to start thinking about this is as we start writing our dungeon and okay, so that kind of pulls them up just a little bit short, but he's moved kind of at us. So that looks pretty decent. So in any case, this might be something we use in our dungeon crawler when we say we maybe go north. We might say, have our dude move towards the center of the room to the north, something like that. And we might want to stop from a certain distance from that point or something like that. whatever we decide. Just something to keep in mind looking at what vector threes are capable of doing. All right, let's look back and see what else we got. We're going to be looking at Lerp and Slerp in a second, which sounds funny, but they're actually mathy things. Let's see. Dot product. It's made of the largest components of two vectors. So we can get the min and max of two vectors if that's important to us. We already saw move towards. I don't know what project a vector onto another vector would ultimately do. Imagine. Example would be a projection is a rail mounted gun that should slide so that it gets as close as possible to the target object when the target object is moving. So you might use project when it's moving. Reflect, rotate towards. This is something that also might be handy. For instance, in our dungeon game, if our guy is facing to the north and we decide we want him to go west, we would probably first have him rotate to look towards the west before he starts moving towards the west. That's also built into one of the Lerps or Slerps, I think. All right. So, but that's something else we can do. And if you remember, I'd originally mentioned that rotations in Unity, it's a pretty high math type thing. It uses something called quaternions. And quaternion mathematics is obviously doable because Unity's doing it, but that's one of those things you would definitely want to rely on Unity to do for you. It's going to make your life a lot easier. Okay. Anything else? And notice here that we do have all the operators for, and we already saw one of them because we tried to determine if two vectors were not equal to each other, right? So all the operators, minus, not equal to, times, divide, plus, double equal sign for equivalency, these have all been overloaded to allow vectors to compare themselves or do math with other vectors in the event that that becomes something that we want to do. All right. So in any case, let's look at something called Lerp. This linearly interpolates between 2 points. Now, this is effectively, let's go ahead and look at it first. This is going to effectively work the same way. I'm going to go ahead and stop printing this dude. Just comment that out. So instead of move towards, I'm going to Lerp. Right? And what you're going to see here is that it basically has the same visual behavior as move towards. Notice though, it did move a little quicker because the way it's doing the math under the hood. Let's see the way they explain it, but it's a mathy thing. So if I click on Lerp, points. So it's saying you might use this if you want to find a point somewhere between 2 points. So kind of like when we pulled up short, you might be able to do that all in a single math. So I don't know, there could be uses for it, I guess. Then we have this other thing called Slerp. This spherically, so let me actually show you what it does. It's kind of a cool look. I don't know if it's a useful look for us. But, you know, kind of keep in mind that these are things that you might want to put into your video games to get certain behaviors. And a lot of this is kind of trial and error just to see what looks cool. So, you know, keep in mind that that's kind of a thing. All right, so let's go run that. And now we're going to see him kind of go in like an arc type thing. It's a spherical. Okay, so he kind of did it a roundabout way. We might want to slow him down a little bit to actually be able to appreciate it. Okay. And if you want to see him kind of pull up on that position, we can change it to be greater than 1.0. So he'll get a little closer. We'll see him kind of finish that final turn. Oh, now he's actually why did he disappear? That's actually interesting. I mean, I think he's visually disappeared, but I don't know why. He's clipping behind something, even though our destination isn't there. Well, I'm not going to worry about it too much right now, but that's a visual thing. I'm guessing if we move the camera back some, maybe that wouldn't happen, but whatever. Okay, so that is the scoop with kind of moving between points and putting some logic around that may or may not be handy, but hopefully this wasn't a major heavy lift. Okay, so now what I'm going to do is I'm going to start a brand new project. I'm going to explain why here in a second. All right, so as our projects are going to be getting bigger and bigger, so I'll go ahead and save this project. Open up Unity Hub. It's like I might be trying to kill Unity anyway, since it's having problems closing. All right. So for right now, I'm just gonna rename that other file. Let's see. In here. Oh, it's in downloads. I'm going to steal that name because I'm going to rename our new project the same thing. So I'm just going to call this guy Test just so we still have access to him. All right. So first of all, let me introduce a website real quick. So there exists out there a website called GitHub. So there is a program called Git that is very similar. In fact, it's probably what was actually used by Online GDB. When you saved your projects and you shared it, and it gave me this link. Behind the scenes there, it would have had to store that somewhere so I could see it. Well, GitHub is a web-based kind of, think of it as like cloud storage that allows us to store stuff up in the cloud related to projects. It's made for collaboration. In our case, we're collaborating with the perspective that you're going to be able to share your code with me. All right, so what we're going to be working on the next few minutes is pretty important. So try to pay attention. I am recording because we're going to do something in a very specific way for our projects so that you don't run into a major issue. All right, and so this is what GitHub looks like. Now, there are Git programs, like Mac already has Git built into it, things like that, but what you will find easiest is to go to desktop.github.com and download GitHub Desktop. Okay, this is a program that will run on your computer, whether it's Mac, Linux, Windows. So in any case, that's you're going to see how we use it here in a second. All right. So I'm going to go into our project thing here again. Now I'm going to create a new project. Actually, let me hit cancel here real quick. I'm going to first remove this project from the list. When you remove a project from the list in here, it doesn't delete it from disk. It just makes it show up not in here, and I've already renamed that folder anyways. Notice it even tells you, if you remove it from the list, the files will still be there. So we're not deleting those files. I just don't want to create a conflict where I have two projects named the same thing, even though we know we manually changed the folder name. All right, so I'm going to create a brand new project. It's going to be a 3D core project. I'm going to name it the same thing I had before, since that was my original intent. This is going to be our dungeon crawler, but I want us to get the source stuff. All right, you can put it wherever you want. I'm going to tell it to put it in my Unity projects folder. So same place I had it before. And I'm going to go ahead and we can leave it connected to Unity Cloud. We may or may not use that, so leave that for now. But you do not need to use Unity version control. We're going to use GitHub instead. GitHub is more of an industry standard anyways, not that Unity version control is necessarily bad. Apparently it works with large files better. And that's actually the problem that I'm going to be teaching you to work around here with GitHub. And that'll make sense here in a minute, hopefully. All right, so make sure you do not have it connected to Unity version control, although I don't think it would actually hurt anything. Just why have an extra thing we're not going to use? But you can keep it connected to Unity Cloud. I'll go ahead and create the project. Now you will need to create an account on the GitHub website. I don't remember if I had asked you to do that before. I know I have a link on, I think on Blackboard for that. And they do allow you to have all the professional level stuff with that, with a student account. So you can apply for a student account. And as long as you do it with your Concordia email, it will just work. So you don't have to worry about too much extra stuff. Okay. So now what I'm going to do, notice here inside of my assets folder, I currently only have a folder called scenes. All right, so now what I'm about to do, I want you to do every single time you start a fresh project. All right, so we can get it up in the cloud. And let me kind of explain as we're looking at it because it'll let me show you. So I'm going to open up Git Desktop. So once you have Git Desktop open, up in the folder somewhere, up top in the drop down, on the Mac, it's under GitHub Desktop. It's probably under File or something on PC. You want to get to, you can install the command line tool if you want to be able to do stuff with GitHub for the command line, if you do like web development stuff and things like that, but we're not going to worry about that. But you do want to go to settings and you want to link your GitHub account. So you would sign into GitHub up here. I've already done that, but you will need to do that with Git Desktop. So when you first get Git Desktop, sign into your GitHub account. You only need to do that the first time. And that's going to be good enough for what we're going to do. All right. So now what I'm going to do is I'm going to create a new repository on our hard drive. Now, the way Git works, and let me actually open up Keynote here just to give us a couple of notes on this. We've all kind of already experienced the benefit of the things of GitHub by being able to just share a link with me earlier in the semester and last semester. But let's talk about Git versus GitHub. So Git is a local folder that keeps track of changes made to files over time. So that if you break your code, you can roll back, things like that. It also allows collaboration where you can have 2 or 3 people working on a project, and it'll kind of give you tools to show like, where maybe if you and I made changes to the same file, it would allow us to merge those changes together. If like I wrote a function and you wrote a separate function, it would allow us to merge them into a single function. We're probably not going to go so deep into GitHub where we're going to be looking at those things. Just kind of be aware that that's one of the tools that you can do. So it is meant for collaboration. But understand that Git itself only does stuff with local things. It creates this, basically what they call a repository is just a folder. And inside that folder, there's a couple of special files that have a period in front of them. It's like a .git. And by default, anything with periods in front of them are invisible when you first look at it. So you'd have to click on hidden to see hidden files if you wanted to be able to work with those. All right. But so Git just manages this stuff locally. GitHub is a website that allows you to store your Git repositories for easy distribution or collaboration. There are other sites that do the same thing as GitHub does. I would say that GitHub is definitely the industry standard. Now, the way that, and it was actually purchased by Microsoft maybe 2 years ago, something like that. All right. Now, they have this lulling process. So Oracle does the same thing. Oracle is a database system that's cost thousands and thousands and thousands of dollars for companies. Yet Oracle will let you download it as a student for free. So you learn their tool and get to use all these things. And then they have kind of a rule about what you can use it for. So that means once you graduate, you go and work for a company as their database person, and they ask you what software you should install. You tell them, oh, go buy Oracle, and they make zillions of dollars, all that stuff. So GitHub is similar. So GitHub is free for students. It's actually also free for any public repository. Now, for us in here, we can make all our repositories public because we're mostly using GitHub as just a way for you to easily distribute your code to me. So you only have to give me a link when you submit your assignments. Okay. But in any case, Git is a website for this, but Git does have a charge associated with it if you want to have private repositories for, if you're working on a video game that you don't want the rest of the public to be able to see. People can they can fork your repository just like you could an online GDB, so you can get a copy of it without changing it. But this is kind of this is what GitHub does. All right, so our two-step process will be creating a local repository, and then whenever we make changes to our application, you push those changes to the cloud. So let's see how we're going to do this. So we just created a fresh Unity project. So now we're going to go ahead and we're going to create a new repository on our hard drive. Now, we could, prior to creating our Unity project, we could go ahead and we can create the repository for our entire project. And if we wanted to, that's not what we're going to do. But if we wanted to, we could. And then there's this thing called git ignore here. If we scroll down, you'll see that there actually is one for Unity. All right. Now, what this does, so Unity, when you first, you probably noticed it. Sometimes it takes a while for it to first open up when you launch it because it's creating a bunch of files. So there's a bunch of files in Unity that don't need to be stored in the cloud because the Unity client creates them. But the issue we run into with GitHub using this for using just the git ignore for our entire project and storing our entire project in the cloud is it'll also save all of your assets like your pictures and things like that, which start taking up large amounts of space. And unless you needed to distribute the pictures and all these other things with other people, which I care more about the code in here. So that's why we're going to do it this other way. But if you needed to distribute everything, you would have to deal with something on Unity called large file support, LFS. And the bugs dealing to get that working on your system can be a little bit infuriating. So we're just going to bypass that even possibly happening by just pretending like this isn't even a Unity project. All right. So I'm not going to do anything with git ignore. And what I'm going to do is I'm going to create my repository name is going to be scripts. So what I'm going to do is I'm going to make our scripts folder inside of our assets folder, our Git repository. So it'll only be our code. As long as you always put your code inside of the scripts folder, it'll only be the code that you'll be sharing with me. Now for the local path, let me go back to our Unity projects here. So here's that new project we just created. So go into the project, go into assets. We wanted to create that scripts folder inside of assets here, rather than us creating it manually in Unity like we've done previously. So I'll just go into the assets folder here, and that's the one I'm going to use. So I wanted to create a repository called scripts in the assets folder. I don't need to do anything with the git ignores or anything like that. Let's see, do I need to make it public or anything? Doesn't look like it. Okay, so I'm going to say create repository. All right, so now as of right now, there's nothing in that repository. I'm going to go ahead and I'm just going to publish it because right now Git is just local. This repository is just local on my computer. So I'm going to publish this repository to github.com. All right. Now you can name it something different if you want. It doesn't really matter. I'm just going to do like a scripts CSC250 spring 2024 dungeon crawler, just to kind of label it so you don't have 20 folders called 20 repositories called scripts up on GitHub. And then another important piece here, make sure you uncheck this button. Keep this code private. That way you can conveniently share it with me. All right, so name it something reasonable, uncheck private so it's a public repository, and just click publish repository. So what we just did there is we created a repository up in the cloud. It currently has nothing in it. I'm going to go ahead and put something in this real quick. Notice now we have a scripts folder in here, even though we didn't create it through Unity. I'm going to go in there. I'm going to right click. I'm going to create a C# script here. I'll go ahead and name this guy player, since we know we're going to need a player thing in here. But for right now, I'll just create that. All right, and that's all I've done in the project to show you how this will work. When I go back to GitHub desktop, notice it sees that a couple of files have changed. All right, so now your process to get that up in the cloud will be this. I'm going to say, okay, well, it notices some files have changed. It wants me to give a summary of what I've done. For most of the time, it's not going to be overly important. We're just going to say made changes, whatever. Okay, but it makes you give a little note of what was done before this commit. So now I'm going to say commit domain. All that does is commits it locally on my hard drive. To get it to the cloud, we then need to say push origin. Okay, so we published it originally. Now we're pushing an update. And just to show you that it's there now, I'll go to my GitHub. Here is this new repository. Actually, that's not the new repository. Here. Okay, here's my new repository. So it's scripts, CSC250, spring 2024. And notice that in here is that player CS file. So what I'm going to have you do is just use GitHub to hold all your scripts and have you submit that. So when you submit your homework, what you'll be doing is you'll be submitting this web link. You could submit that whole thing there. That'll get you there. Okay. So that'll be what you actually submit. Okay. So if you had that, just that link and you clicked it, you would all be able to see this file. I can actually go ahead, I'll put on in Zoom here, I'll put it in chat. You want to just see how that works. So I went ahead and pasted that link. If you click that link, I made this repository public. You should all see this scripts folder. All right, so then for homework, and I will put it up right after class today. I apologize, I must have gotten distracted after class the other day. So homework, make a GitHub account. Download GitHub desktop. Create a new Unity project and use GitHub desktop to create a repository called scripts inside of the asset folder of the new Unity project, just like we did in this video. So you're effectively going to be following this video. Then bring this project up to date with what we have done with our player one and destination for moving toward that destination. And commit all changes and push to GitHub. Submit the GitHub link to your code. And the self-assessment. Say nope. Make sure your GitHub repository is not private. Because if it's private and you give me the link, I won't be able to open it. It'll say that I need to be set up as a collaborator. All right, so make it public and then that won't happen. All right, so any questions on what I'm asking you to do here? So effectively, the homework that was due today, you're going to, if you've already done it, move it into a new project that has this repository tracking the scripts, or do the homework that was due today. And just as at the very end here, I'll go ahead and put the script up. Oh. So there's our script with the code we added to it. You can use Slerp, you could use Lerp, you can use MoveToward, it doesn't really matter. We're going to be changing it anyways. But ultimately, I want you to prove that you're able to share with me a GitHub link with your code in it, stuff from your scripts. I don't need your game objects. I don't need anything else. I just want that scripts folder, and this will make life easy for everyone. So the purpose of this homework assignment is to make sure you can submit all future assignments this semester. All right. Any questions, comments, concerns, bribes? Okay, I will see everybody on Monday, and I'll put this assignment up right now. All right, take care. Have a good weekend.